Right, question number 14. We've got a sequence that starts with 2, and then the next number is 2 root 7, and then the next number is 14, and the next number is 14 root 7. We need to work out what the next term is. So this might look a little bit tricky to begin with, but actually it's pretty simple. This is what we'd call a geometric sequence, because there is a common ratio, something that is multiplying by the previous term to make the next term. And that thing, it's got to be root 7, because to get 2 root 7 multiplying 2 by root 7 gives you 2 root 7, right? You can see that has to be what you multiply by. And obviously you can check that by doing the next one. So you've got 2 root 7 multiplied by 7. Well, root 7 times root 7 is 7, and 2 times 7 is 14. So that works. And then you got exactly the same thing again here. 14 times by root 7 is 14 root 7. So all we have to do is take 14 root 7 and multiply it by root 7. So root 7 times root 7 is, and it's going to be 14 multiplied by whatever that is, which is always 7. And then you're going to get 14 times 7. So 7 times 4 is 28. 7 times 10 is 70. So 70 plus 28 is 98. There's our next term, 98. The nth term, now that seems a little bit more tricky, but all it is knowing that knowing the formula for a geometric sequence is fairly simple. That's all we have to know for this question. So the term number, the term that we want to find, is equal to the first term number, and this is our formula, multiplied by the common ratio, and then that is to the power of n minus 1. Okay, now that is the thing you can remember. You can remember this this is effectively the notation for the first term of the sequence, right? So first term multiplied by the common ratio to the power of n minus 1. It's always n minus 1 when you've got a geometric sequence like this. So the first term we can see is 2, so we're going to get 2, and we're going to multiply that by the common ratio, which we found to be root 7 in the first question, and that's going to be to the power of n minus 1. And it is actually just that simple in the end, right? But it's 3 marks because there's a tricky formula maybe to remember. I'm not sure why it's 3 marks, but it is. And that's what we get for this question. So there you go. Right, C, you've got to find the value of the 21st term divided by the 17th term. So this just requires us to use the formula, substitute these numbers in. So n always represents the term number. So if we substitute the term number in, we're going to get 2 multiplied by root 7 to the power of 21 minus 1, and then divide that by 2 times by 7, 17 minus 1 is the power. So that's simply going to be 2 root 7 to the power of 20 over 2 root 7 to the power of 16, which we can cancel the 2 straight away. And root 7 to the power of 20 divided by root 7 to the power of 16. Use your indices rules here, same base number. So you're going to end up with root 7 to the power of 4, because you're 20 take away the 16. If you divide and you're allowed to take away powers. So you get root 7 to the power of 4, which if you were to expand just to show you what that would be, you got root 7 times root 7, and then that's going to be 7, and then you've got multiplied by root 7 times root 7, which is also 7. So you end up getting 7 times 7 as the final answer, which is 49. So that's what you get when you divide the 21st term by the 17th term. You get 49. So seemingly tricky topic. It's new to the GCSE specification as well. Geometric sequences, look it up. Knowing the formula is really useful. First term multiplied by common ratio, term number minus 1 is what you need to know. And we could derive that as well. I'm not sure that we have to, be able to derive the formula, but we have to know the formula, how it works, in order to find the nth term to a particular geometric sequence, which then helps us answer this question as well.